But yeah, thanks, Tanya. We're just going to go over a few things today that are going to be available in the new version of SMS 13.4. We've been working on different interfaces and changes over the last couple of months, and wanted to go ahead and show you an early preview of those. It's the SMS 13.4 is already out in beta, but unfortunately, the USACE does not allow us to put beta versions on the app portal normally. And so I doubt it's going to get approved. We may try it with a later beta and just see what they say. But the expected full release for this version that I'm going to be showing a little bit of today is going to be around April timeframe. So hopefully it won't be too long, and then it should be on the app portal or the software catalog, whatever they're going to change it to at sometime soon after that. So a few things that we've been working on are new tools for working with hard bottom data sets in CMS-Flow. Also, there have been 4 structure types for CMS-Flow that have been available since about 2011 or 12. But we did not really have an interface for those in the in SMS for the longest time. Users would have to manually do some things, and it was a lot of trouble. So we've been trying to implement something to make it a little bit easier for people to use these different features for CMS-Flow. And then I'm also going to briefly show a new GenCade user interface that we've also been working on. That's been a little bit longer time frame and work, but we're finally getting there, and it will be in the next version for testing, while we will still keep the old interface just in case. So there'll be both of those in there. So for non-USACE users, I have a link down below that you can go to and download this version. If you don't already have a license, you can do an evaluation on your personal computer for about a month or so. But anyway, should be good to go pretty soon. So starting out, I'm going to be covering about hard bottom within the CMS. We used to have a pretty nice interface back in SMS versions 10 and 11. But then when they went to the newer type of interface for working with simulations and things like that, SMS 12, that particular feature was lost, and it's been gone ever since. And so it's really been a headache trying to deal with implementing hard bottom in certain areas, especially for jetties and things like that. And so hopefully this new interface will help us out a little bit. So we have a couple of different options that the user can choose, from totally non-erodible to limited erodibility, whether it be a distance below the bottom or distance below the actual mean reference water level. So quickly showing how it used to be, there was an option to select some cells, specify the hard bottom, and then it would pull up this interface. And in the new interface, it's done a little bit differently. We are going to be using polygons that the user can define now. So we can select the jetties in particular and assign those as non-erodible, or other areas that are in the middle of a channel, say where there's a lot of strong flow and maybe most of the movable material or erodible material is already gone. So we can define those. I'll show a little bit of this. I thought about doing a demo for this, but I decided for simplicity, and so it's easier to reference on the web, to just put this as screenshots with a little bit more explanations. So the new interface, basically you go into your coverages and you select a hard bottom coverage, and then once you define the different zones, then you can come in here and specify one of these 3 types. And 2 of these have actual values that you can enter there. And then once you have all that set up, then you're ready to go. And we can use a different tool to actually create that data set, and I'll show that a little bit. Just so you guys can understand a little bit more about how the hard bottom is implemented in the SMS, I have this slide here just as a reference. So we see the shoreline, maybe it's a jetty there, and it goes down to the bottom, and we've got the water and a mean water level that's referenced for the project is set. It could be mean sea level or an 80D88, whatever the user chooses. And then there's a Z value that goes down from that mean water level down to the bottom. And then the hard bottom layer normally sits below that at some point. And then this is that layer that we're trying to reference with these different tools and different abilities here. So one of the examples I showed was a totally non-erodible example. And so that might be this situation where that hard bottom layer is right at the bottom of where the, or right at the same level as the bottom of the sediment. And so you have that section there where they're actually overlapping. And so you could select those cells and then say, hey, these are non-erodible. It'll allow you to accrete material on top of it and then re-erode back down to that hard bottom again. And this is typically used for structures like jetties and breakwaters and things like that. But there may be other situations where you might want to provide this capability as well. And so the next type is a specified distance. And so this would be where the hard bottom layer is a certain distance, and you know what that distance is from sediment cores or things like that, where you may have gotten some answers out there. And so you would provide information for these cells with the exact distance from the bottom down to that hard bottom layer. So that's a positive number and distance down. And then the other option is to specify the hard bottom as a distance from the actual mean or reference water level, whatever the user chose for that. And so in this particular case within the SMS interface, these numbers are going to be negative because they are elevations now inside the interface. And so we would provide that distance down from the water level to the hard bottom layer. Once those are all set, then the user would come in and use this other tool. So there's this new tool here, toolbox that has been implemented, I think, since 13.3. So if the user clicks this icon, he pulls up a toolbox, and it's got a lot of different tools for different models and different capabilities. And there's now one in there for CMS-Flow. So they would just open up that CMS-Flow option, click this hard bottom dataset tool, and then run that tool, which will pull up a page and ask for bits of information. And I'm not showing it, but on the other side of this, it brings up a wiki page where there's some more information, more guidance for what these values may pertain. It may have some equations or whatever, depending on the tool that you're running. So in our case, all we need to say is what grid that we're going to be applying this data set to, which coverage that we just defined for those hard bottom data sets or polygons, and then a name for the data set. And then once we click OK, it goes out there, computes pretty quickly, and then you end up with one big data set that has all your different polygon information included. And where there were no polygons, all the other cells are specified as freely erodible. And so you don't have to worry about specifically saying that all the other cells have no limit to its erodibility. Any questions on any of that? I know it's something that we've been asked for several years now at different workshops that we've been providing. And finally, I'm glad that we have a tool to come back and specify this again. Anyway, I'm going to move on. So now we're going to go over some CMS-Flow structures. And so the first one that we're going to talk about here are culverts. As I mentioned earlier, the culverts and all the different structures have been around in CMS for a long time. There was a series of CHETNs that were published that we have references to on the website that you can go and see more information on how that was initially supported within the SMS interface. But for now, we're going to change this up a little bit, and we're now working again with coverages. And so for the cohorts, basically you go in and you select, hey, I'm going to add a map coverage. It's for the CMS model, and it is a structure. And so you add that structure, and then for your specific area, you would go in and define the culverts. And for culverts, and it's the only one of these that I'm going to be giving specific guidance that it has to be done in a certain way. But for culverts, you have to provide the feature arcs, starting them in a bay type situation and moving to the seaside, or where the typical flow would be coming from. It may not be a seaside, but that's how you have to think about it. So in this case, we would have, and this is Poplar Island in Maryland here, or one of their wetland cells. And so there's a road that goes across here, and there's a series of 8 culverts that are implemented right here. And so we would define the first point for each culvert on the bay side, and then cross it over and connect it up with a computational cell on the seaside. And so we do that and create a series of different arcs. And these arrows help us know that, hey, we did create those in the correct direction. So we see that they go from this side over to this side. This isn't always on, so you may have to enable that. And I give some directions here for how to do that in your display options. Once you have the arcs created, then you would right-click each one and then go into the properties dialog and enter a little bit of information parameters for each culvert. So in this case, there's a type of culvert, and that could be either circular or a box. And then if it has a flap gate or not, the width or radius, and then a bunch of other different parameters here. And then there's some other things, pieces of this that SMS actually provides for you, such as the elevations for each side of the culvert and the angle of that culvert in relation to the rest of the grid. And so that your user does not have to decide, hey, what is this angle? I can't compute it very easily. SMS will do that for you. And then once you have all of these set and everything set up like you want them, then you would just apply that to your simulation like we do boundary conditions or any other thing in the new interface for CMS-Flow. The other 2 types are pretty much similar. So for weirs, this is an example here at Rudy Inlet in Virginia. And we've got a weir situation here on the South Jetty. So there are a couple of restrictions for this. For weirs, all cells and all neighboring cells must be active. So you can't have a weir directly next to or on top of non-computational cells. And so that's just something for the way we calculate things in the CMS. We can't necessarily infer things from cells that aren't there. Another restriction is that all neighboring cells have to have the same resolution. So you can't go from one side of the weir at a smaller resolution over to the other side of the weir with a larger resolution. And each weir arc must exist in the same row or column. And so here's one implementation of how we have this for our example. And because we can't cross a row, we actually have to have 2 separate weirs. And then the common point is right here in the middle, and they are separated with different rows. A little bit of guidance diagram here for what is what's allowable and what's not, and some reasons why. And then once you have the arcs created, like we mentioned earlier, there's another dialog that you pull up to actually give more information. You have to say, okay, for this weir, which side is the direction of the seaside from that. I look for a way to automate this, but I can't necessarily find one easy right now. So we still have to define the orientation, whether it's a sharp or a broad crested weir, and then some other information here and different types of computing that weir flow. And then just as we did before, we would assign that structure or apply it to the grid or the simulation like we did before. And the last added interface is for tide gates. I don't have a good real world example that we've put together, but in this case, we have just an idealized grid. I think this was initially set up to mimic the area for Humboldt Bay, maybe. I can't remember exactly, but we have this grid set up. And then we assign a tide gate just in the middle of it. It's not necessarily where you would normally have a tide gate, but just for the examples, this is what we've done. So direction doesn't matter on which way you start this. And there are no really other restrictions other than, you know, the ends and all of the pieces on here need to be computational, just like they should be for all the other structure types. And so for tide gates, there's different ways to implement that. So you can provide a regular time interval and frequency or designated times. So I know that at 3 different times over this week period, this tide gate was opened and then shut, and you can mimic exact or reproduce that exactly as you need with designated times. You can also turn on an open for ebb and close for flood option. And that does take into account which side is the seaside or bayside. And there are a couple of other dialogues, one for the designated times, and then the other options here as well. So it's pretty much, these are all somewhat the same as far as how to set them up and how to access the properties. And another one that I'm not showing here are rubble mounds, but that's been in the interface for a few years, and so I'm not going to go over that. It's done pretty much exactly the same way, but instead of arcs, we use polygons to designate specific collections of cells and then populates them in and answers for that. If you need more guidance on how to do any of these 3 that I'm showing here or the rubble mounds, there is guidance on our wiki, and I have a link right there to that page so that you guys can go and investigate a little bit further. So moving on, I know this is going pretty quick, but we've got a new GenCade user interface. And so we introduced GenCade, I don't even remember what year it was, 2008, 2009, and we developed an interface for it in SMS, I think 11.0 or 11.1 back in 2010 or 11. And so there have been really no real changes to that interface since that time. And it's gotten a little bit clunky, and some things don't work that well. Adding times for the waves, things like that have been problematic. And so we thought now would be a good time to modernize this interface and bring it in and make things a lot similar in the way it operates with simulations, and especially now that we're able to add in some Monte Carlo type capabilities for the GenCade. So the difference is in the map coverages, there's an old GenCade option that's going to remain for probably throughout SMS 13.4. But users that want to enable the new interface and test it or use it, just contact me and I'll give you the instructions on how to enable this new section that basically takes in 3 different coverages, and each one is specific to either the grid or the arcs associated with events and structures, or the points that are associated with modification or tide or wave gauges. And so just a couple of examples of what things might look like in the new interface. We listened to through some of the workshops, and there were a lot of problems being able to visualize and see these arcs well, and to understand which arc was attached to which type of structure. And so we've tried to make these a little bit larger, and we've added text on each one of these objects so that they can be easily identified. And then it's also got an interface in there for the user to be able to modify the colors and the sizes of these two as they see fit as well. So working with the grid separately, we had a 1D grid that the user had to create, and we still do that, but it's done a little bit differently now. I'm not going to go into all the details, but we have some guidance out there. But basically, instead of creating a 1D grid, you just basically have to define a beginning and an ending point for the line and the grid. And then the refined points are also in that same coverage. And so you would provide any number of refined points to make the sizes of the grid spacing smaller around different structures like groins or whatever you might need. Wave and tide data are now on the point attributes, and they're separated out from all the other attribute modification types. And that makes it a little bit easier to identify which type is which, and to also be able to access the wave times or the tide gauge times a little bit easier and better. And then a few other quick changes that we've done over the last two and a half years. Yending has been improving or adding some new capabilities into GenCade. And so those are Monte Carlo type simulations and calculations. And then also the capability to do cross-shore component analysis for the movement of the sediment around areas. Those options are now available in the new interface, and they have a place in the model control. All of these use, you'll have to update your GenCade version to 2.0, which is included with the new SMS, if you want to use this newer interface. Also, water level, users had to hand enter that data into a file and link it in themselves. Now we have an interface that actually has a table where you can enter that. And we also are able to pull in the solutions from GenCade and visualize those a lot easier in a standalone window, and move through the times and be able to see things a lot easier. So I know that was a lot in a relatively short amount of time, 25 minutes, but that's pretty much all that I was going to go over. Are there any questions